So let's proceed to the equilibrium of particles in 2D and its free body diagrams. So since we already know how to determine the resultant force and then you know how to create your free body diagrams, so I think what's new here is that the condition of the equilibrium. Okay, so I think what really applies here is the third law of Newton. So for every force, there's an equal but opposite reaction. So if we're going to apply this one in our system, so most likely our resultant force will be equal to zero because the left and right forces will negate each other and also the upward and downward forces. So that's why it's called equilibrium. So it's balanced. So the total resultant force of which is equal to zero. So for example, I'm pulling 30 newtons. So the object must be 30 newtons heavy as well, so that there's no movement or for equilibrium to be achieved. Okay, so what is considered as a particle in this course? So large bodies or small bodies can be referred to as a particle. So most likely we're going to shift our subjects or our system into a particle because it's easy to determine the FBD. Okay, so for example, even though that we have a box to consider in our problem, so once we create our FBD, so that box will become a particle, and we refer that particular particle to its center of gravity or center of mass. Okay, so when the size and shape of the body have no effect on the response of the body to a system of forces. So meaning we're trying to ignore the deformity of the body as of the moment because that will be discussed in another topic. So the mass of the body can be assumed to be concentrated at a point and the shape is neglected. So this is what I meant earlier. So instead of a box, which is complicated to be analyzed, so we refer to the center of gravity of the material or center of mass, which is at the center of the material. Then we convert it into a particle, and in that particle we can now place our FBD system or force systems in going towards that particular point or whatever forces that you're going to apply in your system. Okay, so the particle is said to be in equilibrium when the resultant of all forces acting on it is zero. So I think the last topics that we have discussed, our resultant force is not equal to zero. Now, since our our forces are now in equilibrium, so the resultant force is zero. So one good example of which is this diagram here. So 100 newtons on the left and then 100 newtons on the right. So meaning if we try to add up the forces, so the resultant of which is equal to zero. Okay, so I think it's easy to understand what equilibrium state is. So as long as the resultant force is equal to zero, so it's in equilibrium. Okay, so I think it's an essential topic because later on when you go on designing buildings, so you need to achieve the equilibrium state of your system of your structure. For example, um, your your building can handle this much force, so meaning you can only apply that certain force and you cannot exceed on that particular amount of force that your building can handle. Para equilibrium siya, di ba? So of course, in actual practice, we're not trying to achieve equilibrium because if you try to reach equilibrium in our design, So it is in the condition of impending failure. So it's about to fail na, diba? Because it's in equilibrium. So of course, since we are practicing safe engineering or safe architecture, so we only allow forces lesser than the required amount of force that the building can handle. So later on, once you reach reinforced concrete design, so you still go back to this particular topic in equilibrium forces. Okay, so if you have multiple forces, so if you try to draw the FBD, so let's say you have three forces. So if you try to draw the triangular force system, so notice that there's a flow. So mag-circle na siya. So it will just rotate because the system is in equilibrium. So compared to the previous topic that we had, so the the resultant force will be included in the force triangle. But since our system is in equilibrium, so notice that there's no resultant force present in the triangular force. So only the component forces are present. There's no resultant force. So let's say if you have multiple forces greater than 3, so it will still create a closed polygon. So a closed polygon will give you a equilibrium force system. So again, notice that there's no resultant force included in your force polygon. So only the component forces. Okay, so since we are going to use equilibrium in our problems that we're going to solve later, so we still have to use the summation of forces x equals 0. So this time it's equal to 0 because again our our condition is in equilibrium. So again, if you add the forces, the resultant of which is 0. So of course the resultant force is 0, so meaning the component forces, let's say the x and the y components are also equal to 0, di ba? Kay ang ang bigger nga r, which is the total resultant, is also 0. So meaning the component resultant of which also is also equal to 0. Excuse. Okay, so I think you are now familiar with the summation of forces x and the summation of forces y. So for a vector, so I think the importance of vector is just the direction of your forces. So again, this I and j here is just indicating the direction of your forces. So I meaning it's in the x direction, j meaning it's in the y direction. So again, we are going to use two equilibrium equations. So summation forces x, then summation forces of y is equal to 0. Okay. So these are the two equations, and of course we have a third equation, which is the summation of moments is equal to 0 also. So this will be important once we reach your parallel force system and your non-concurrent force system. But as of the meantime, we're going to utilize first your summation of forces x equals 0 and summation of forces y equals 0. So again, balik-balik na siya. So equilibrium, so we have 0 resultant. Okay, so our objectives is we're going to determine and apply the conditions necessary to produce equilibrium for coplanar force systems. So meaning coplanar on the same plane. And then we shall apply what we have learned from the previous discussions about components of a force and moment of a force. So what we have discussed before midterms can still be applied here, and the only new thing here is that our condition is in equilibrium, so meaning there's no resultant to be solved in our system. Okay, so for example, we have this problem here. So again, since we're going to use equilibrium condition in the forces. So if we're trying to draw the free body, the FBD of this problem, so notice that point A can be isolated into this manner here. Okay, so notice that your force, I mean your weight here, is going downward. So of course, this can be applied in the tension wire as well. So that's why you have a downward force in point A. And then the tension, that's why it's T, because that's the tension of cable AB. So tension of cable AB. Then the other one is tension of cable AC. So of course tension, that's pulling, di ba? So meaning since you are pulling, it's outward direction. Okay, so it's outward direction. You are pulling against A. So that's why the direction is outward. Okay, so I think we already applied the particle system, the particle concept here. So from this complicated diagram, so you transform it into a particle. So let's say point A, and then all the forces are acting at point A. So what's next here is we're going to solve the value of your TAB, the tension of AB, and then the tension of AC. So I think that's what you need to do here. You just have to solve the unknown forces in the system to achieve equilibrium. Okay, so the FBD is a sketch of the body showing all forces that is acting on it. And then the isolated view of a body is called a free body diagram. So meaning at point A you can create an FBD. At point B you can also create another FBD. Same goes for point C. You can also create another FBD at that point. So daghan-daghan siya but per point ang iyang pag-create sa FBD or per particle. Okay, so your FBD is also included. So the FBD also includes the external forces that acts on the body. So internal force, external force as well. Okay, so the steps in making an FBD, in making an effective FBD is that you need to decide what body or point needs to be isolated or analyzed. So once you have decided that you want this particular point to be isolated, and so next is you need to prepare a sketch of the external boundaries of that selected body. So meaning you need to include the need to observe the forces that will include on that particular point or body. And the next is you present all the forces. So present all the forces, known or unknown, and also the external forces as well that is acting on that particular body. And then lastly is to label your known forces with their magnitudes and their directions. So you can use letters to represent magnitudes and directions of unknown letters. So one great example of this is katong tension AB, tension BC, or you can also use force AB if you don't want tension, or force BC if you're not yet sure of the direction of your force. Because tension is pulling away, so meaning it's outward direction. pushing is compression. Okay, so general procedure for constructing FBD. So for flexible cable of negligible weight, so in this particular point, you can just put tension here. So tension and then unknown angle theta. So from this one, it becomes this. So you can also have point na lang and then if you don't want to draw the box again, you can just have a point here and then the arrow is going towards that direction. And then you create a hidden line and then the angle theta. Okay, so for example, you have a frictionless surface. So let's say this one is your object. So again, for every reaction, there is an equal but opposite reaction. So the normal force is perpendicular against the surface. So you need to create it in this manner. So for this one to be a perfect drawing of FPD, so you create a hidden line here representing the surface. And this one is the point. Then you can also place the weight here. So weight is again vertical, diba? Okay, so next is a roller support. So roller support are just a perpendicular reaction against the surface. So direct siya na. So again, the roller is a perpendicular reaction to the surface. So meaning na inyo pa na i-drawing ang iyahang surface here. So if you have a friction, so what is added here is the frictional force. So usually in physics, this F here is represented as F sub F. That's the frictional force. So if you have a pin support or a hinged, so you have two forces acting on your pin support. So that's why you have Rx and then Ry. Reaction in the X direction and then reaction in the Y direction. Then for cantilever, is you have three. So you'll be having a support here, a vertical reaction, a horizontal reaction, and a moment. So that's why you have three unknown forces here. So for letters E and F, so these will be the topics in the later category of your equilibrium forces, which is in the parallel force system and the non-concurrent force system. Okay, so let's try an example. So a homogeneous cylinder with mass of 250 kilograms is supported against a smooth surface by a cable as shown. So this is the cable AB. This one. So determine the forces exerted by the cylinder, by the cable, and by the smooth surface at contact point C. Okay, so the mass of the cylinder is this one. So this circular figure here is your homogeneous cylinder. So the weight here is this point. That's 250 kilograms. So of course, take note that since we are trying to achieve equilibrium, so the force of the cable must be opposite of this direction. So it must be going up. Diba? And then since it's going up and to the left, So again, for every reaction, there's an equal but opposite reaction. So meaning there's a force here as well against the surface at point C. So if you can imagine, I think you can already achieve equilibrium in this state, in this condition. So what's left for us to do is we need to draw the FBD first. So in drawing the FBD, so we're going to isolate the particular body of the system. Okay. So let's say this one is at point B. So we have an unknown tension here. Let's say tension AB. And then our force going downwards, that's 250 kilograms. And then an unknown reaction. So let's say RC lang siya, di ba? Or if you don't want RC, R sub C, for you not to be confused, you can convert this one into H, meaning horizontal component of C, or C sub H if you don't, to avoid confusion. So C and then its horizontal component, C sub H. Okay, so this is your force system. Okay, so notice that what we have created earlier is now this one. So yeah, is FAB lang, and then ours is TAB, and then instead of C sub H, the horizontal component of the unknown force is F sub CB. Okay, so of course, for us to be able to identify the angle, so we need to make use of the triangle. Pasok na siya. So this one is 400 going towards here. And then the radius of your cylinder is 100. So meaning by tangent function, you can identify the angle alpha here. So alpha here is the same alpha in the other direction. So translation of axis. So alpha against alpha. Alpha is 14 degrees. Okay, so again in determining the unknown forces, so how many unknown forces we have is we have two unknown forces, that's FAB and F sub CB. So meaning two unknowns, we have two unknowns. So in order for us to solve the two unknowns, we need two equations. Okay, so we have the summation of forces x equals 0, and then the summation of forces of y equals 0. So meaning the number of equations will depend on how many unknowns that you are having. So for example, if you have 3 unknowns, you also need 3 equations. So that's where the summation of moment equals 0 comes in, for you to be able to solve 3 unknown forces. So I think that's the maximum unknown forces that you can solve in a system, only 3. So if you are solving for more than 3 unknown forces, so I think that's already an advanced topic in engineering. So in our condition, so we'll just solve 3 unknown forces at maximum. So again, if you have 2 unknown forces, you're going to need 2 equations. If you're going to solve three unknowns, so you need three equations as well. Okay, so in summation of forces x equals 0, so f sub cb minus fab sine alpha equals 0. So f sub cb is a horizontal force going to the right, so that's positive. And then the horizontal component of your fab is going to the left, diba? Left and then up. So meaning it's a negative horizontal force. So using a triangle, separate triangle. Sorry, it's upward, upward. So let's say this one is alpha. So this one is FAB. So using sine function, so sine alpha is opposite side, that's the horizontal component. Let's say that one is x. So x all over FAB. So isolating x, so you have FAB sine alpha. So that's why you have this answer here. So again, since we are in equilibrium condition, so it's equal to 0. So f sub cb minus fab sine alpha equals 0. So since these two are still unknowns, so we let this one as the first equation. So two unknown forces as of the moment. So in your vertical force, so I think it's super easy because you can solve the vertical component of AB. So can use cosine alpha is equal to, let's say, y all over FAB. And then y component of the force is FAB cosine alpha. So that's what you have here. And then minus 250 times 9.81. So 250 kilograms is still mass. And then you make it a force by multiplying gravity, which is 9.8 meter per second squared. So kilograms times the gravity, it gives us a Newton force. So of course, the vertical force is also equal to 0. So once you're able to calculate your FAB, so FAB is equal to 2525.4 newtons. So you can now solve it using equation number 1. So by plugging in equation number 1, you can solve your other unknown force F sub CB. So with the force of AB as 2525.4 and your F sub CB 610.9 newtons, so it will create an equilibrium system wherein the cylinder mass won't be moving left or right. So there's no movement involved here because your system is in equilibrium. So alright, so do you have questions so far? Okay, so no question. So I hope it's clear kay murag ha? Hello? May question? Okay, kasi nasa pra to. So I hope you get the idea because it's the same as what we have discussed before, but this time there's no resultant force involved in the system. Okay, so I think this one is already done. So let's try solving sample problem number 1. So you have in a ship unloading operation, so a 3,500 automobile is supported by a cable. So this cable here, cable AB, let's say that's force AB. And then the rope is tied to the cable and pulled to the center, the automobile over its intended position. Umot na unsa na siya pag English. Sinasayop ni siya o copy paste. Okay, so what is the tension of the rope? So meaning the rope here is this one, the force AC. Okay, so since the man is pulling the rope, that force AC. So meaning that's pulling away, so it's going towards this direction. And then the cable is supporting the car, the weight of the car. So meaning it's also tension because it's pulling, it's not pushing the car away. So of course, since it's carrying the weight of the automobile, so the direction is also opposite of the weight. So of course, this one is the weight. So from the center of mass, so this is the weight of your car, 3,500. So if we're going to isolate your A, so this one is your FAB, then this one is your FAC, and then downwards is the weight of the car, which is 3,500 pounds. So you need to create also the angle. So let's write an imaginary y-axis and also x-axis as well. Okay, so this one is 2 degrees. So also this one is also 2 degrees. This one is 30 degrees. All right. So next step is we're going to create your equation forces. Okay, so as you can see here, sakto on drawing, di ba? So karon is it's using na sad T. So ganina nag-use tag T, ang F sa lang nigawas. So karon nag-F ta, T sa lang nigawas pod. Alright, so if you want to create a force polygon or force triangle, so you may do so, but for me it will just create confusion because in some cases it's important to draw the force triangle, but in other cases pwede ra pod siya dili ra siya i-drawing. Okay, so we can solve it using the summation of forces equals to 0 as what we have determined earlier. So let's try to write it here. So it's so summation of forces of x equals 0. So meaning we're going to be determining the lang ikwana. I change ang color lang. So we're going to determine the horizontal component of TAB and as well the horizontal component of TAC. So since these forces can be drawn into a triangle, so you can just use Pythagorean theorem, diba? Or a corresponding trigonometric function. So in this case, for the horizontal component of TAB, so that will be TAB. So that's going to the left. So let's try to solve lang sa the positive version, meaning TAC, because it's going to the right. So TAC cosine 30 degrees, and then minus TAB sine 2 degrees equals 0. Okay, so again, this one is the 2 degrees, this one is the 30-degree angle. So adjacent, that's why it's cosine for TAC. Ito lang ibutang dire para yung malibog. So this one is sine 2 degrees is equal to the x component then over the hypotenuse. So that's why the x component is equal to TAB sine 2 degrees. And then for the other one, that's cosine function. So cosine 30 degrees is equal to x all over TAC. So the x component is TAC cosine 30 degrees. So the other one is negative because again it's going to the left. The other one is going to the right. Okay, so next is our vertical component. So summation of forces y equals 0. So going upward first, so you have TAC, TAB I mean, cosine 2 degrees, and then minus TAC sine 30 degrees equals 0. So di pa equals to 0, so we need to subtract first. We need to subtract also the weight of the car. So minus 3,500 is equal to 0. Okay. So if we're going to solve this one, so since both are two unknowns, two equations, so you may use your calculator. So mode 5, masura na siya. So mode equation, so if you're using 991 ES plus, so that's mode 5. So look for the option wherein number 5 and then ang description is equation. And then if you press 5, what will appear are a series of options, I think 4 options. So you're going to use number 1, which is in the format of ANX plus BNY is equal to CN. So if you click this one, so it will give you a tabular mode, which is ABC. So it corresponds to the coefficients of x and y and then the constant on the right side. So let our x be, let's say TAB, and then your y component be your TAC. So medyo complicated siya. So but if you just follow the format, so again, atong i-isolate riya. So let's try to rearrange your forces of x and y. So TAC cosine 30 degrees, then minus TAB sine 2 degrees equals 0. Then for the other one, so this one is this one. And then negative TAC, so let's try realigning our equation. So that's sine 30 degrees minus, plus TAB day, cosine 2 degrees And then we transfer the constant on the right side. So that's 3,500. So if you're going to plug in the details of your in the calculator, so ano muna siya, 1, 2, di ba? Then A, B, and then C. So again, we need to follow the format. So in the first line, that's the first equation here. Then second equation. So 1 and then 2. So you plug in 30 degrees. Then here is negative sine 2 degrees. And then for C, it's 0. Then this one is negative sine 30 degrees. Then plus cosine 2 degrees. Then equals 3,500. Okay, so the answer for the first variable x, that's TAC. So TAC is equal to 144.03 pounds. Then the y component, the other component, TAB, the tension of the cable, that's 3,574.19 pounds. So if you try to verify it with the other answer, so notice that TAC, no? Oh, sakto ra siya, di ba? So TAC is this one, the same as the answer in the calculator. And then TAB is 3,574 lang atong na-solve sa calculator. But here it's TAB. So you might wonder, where did this solution came from? So if you want to use the solution, so you need to utilize the force triangle. Ano siya? Because you'll be using sine law here. So this one is nagamit siya og sine law. So if you want complicated solutions, so I mean if you don't want to use the complicated solution, so marag di siya complicated, so easy siya, but basin difficult siya sa inyong part if you want to create the force triangle. So just go to the basic concept of summation of x equals 0 and summation of force y equals 0. So, but if libog siya, if na katong sa conversion, so you can also use the version presented in the screen, which is the force triangle, and then nagamit siya og sine law in order to solve for the tension of cable AB and AC. All right, so do you have questions so far with regards to the problem? Or base naglibog na? Okay, so I think there's no question. So let's try to proceed with the second one. So processing pa. So just try to review lang siguro. So murag think kung ako ay pabuton murag pidira dili ko mo discuss kay base niya sa akong pag-discuss basin naglibog mo sa mot ba. So sige lang, ako lang i-upload ang presentation as well sad. para inyo siyang ma-review. Okay, so next is we need to determine the tension at AC and AB. So tension on this part here. So tension meaning it's going in this direction. Tension, di ba? Pulling. Tension is pulling. Then this one also here is tension. So again, since we are achieving equilibrium condition, so meaning there's no displacement being involved in the figure or in the system. So diha ra siya ang inyong 200 kilogram force. So if we're going to create the force system, so this is your tension BC. This is tension AC, and then this is your 200 kilogram force. So again, this one is still 200 kilograms, so this one is still mass. So for this one to be converted into the weight or the force aspect, so that would be 200 times 9.81, 9.8. So mass times gravity. So this will give us so 960 newtons. Right? So again, if you don't want to create the force triangle, okay, basin maglibog mo if we're going to create the force triangle. So you can use the summation of forces x equals 0, and then summation of forces y equals 0 as well. So we're going to create an imaginary x and y axis here. Okay, so if this is 75 degrees, so the remaining part here is 15 degrees. So same goes here, 15 degrees, because 15 plus 15, 15 plus 75, that's 90. And then since this one is a right triangle, so 90 plus 90 is 180 degrees interior angles. All right. So summation of forces x equals 0. So tension AB, so 75 degrees. So that will be sine function, diba? So if you try to draw, so ako lang i-clear ang ko na. So if we try to draw the system components, this one is the horizontal aspect. This one is the vertical aspect. This one is the horizontal aspect going to the left since it's tension, then going downwards. Okay, so for the x component, that will be TBC, and then sine, cosine, cosine. So cosine 75 degrees, and then minus TAC sine 75 degrees is equal to 0. So that's our first equation. So the second equation is now the summation of forces y. So again, since we have two unknown forces, so we're going to utilize two equations. So going up first because it's a positive value. So this will be TBC, and then sine 75 degrees, then minus TAC, so cosine 75 degrees, minus the 960 Newton weight. So if you want to isolate the constant on the right side, so you may do so. So I hope you understand why it's sine 75 and cosine 75. So if you want to draw the triangle again, so you can see that it's cosine and sine for the respective tension forces. Okay, so dire if ako yung isolate ni, so this one is the 75-degree angle, this one is the x component, this one is the y component, this one is tension BC. So notice that the x component is cosine, the y component is sine function. Now for the other triangle, this is 75 degrees. So this is FAC, TAC, TAC. This is the y component, this is the x component. So x component is cosine. Balide. That is the 90-degree angle. Wait, so this is the 75-degree angle. So this one is sine, for the x component. Then for the y component, it's cosine. So this is the second equation. So again, you may use mode 5. So mode 5. So press mode, press 5. So 5 is the equation. So I don't know for the other brands, but just look for the equation in the mode button. And then go to the first one, that's the equation of ANX plus BNY equals CN. And again, it will give you this particular table, 1, 2, and then A, B, and then C. So you need to follow the coefficients because A, B, and C are the coefficients or the constants. So coefficient, and then the constant. Okay, so you place cosine 75 here, then negative sine 75 here, and then 0. And then you place sine 75 here, and then minus cosine 75. Then at the last one is 1960. Okay, so sorry kay sayro kay saba kayo. Mga kuhanes lang, mga ihas na sila mga tao. Okay, so for the answer for TBC, so TBC is equal to 2186.10 newtons. And then for the tension on AC, that's 585.76 newtons. So these are the answers. Okay, so if you want to use the force triangle, so this is the force triangle, so it's much easier compared with the katong mano-mano nga method using the summation forces x and summation forces y, but ito siya ang super basic approach in solving the unknown forces for your equilibrium system. So if you want to use the shortcut, which is a bit advanced, so you may do so. the answers are still the same, di ba? But mo-differ lang siya og mga couple of units. Alright? So do you have questions or clarifications or processing ba? Okay, so if you have no questions, so let's proceed with the last example. Then I think we can now dismiss, and then I'll give you the assignment in the Canvas course. Okay, so the cable and boom shown in the figure. So this is the cable here. And then this is the boom. So for those of you who don't know what a boom is, kanang murag sa boom truck, kanang murag murag mini crane sa likod sa truck, ana siya ang boom. Okay, so it supports, so the boom is supporting a load of 600 pounds. So that's the force here downwards. So determine the tensile force T in the cable. So meaning tension. So this is going outward, tension, di ba? It's pulling. And the compressive force force C in the boom. So meaning compressive, so meaning that's going against. So it's pushing, di ba? Compressive, pushing. So that's what you need to do in this example. So if you don't, so let's try creating the force triangle if you don't want the, if you don't want the katong mano-mano method, okay, para madali ta. So let's say we isolate, so we create the FPD first. So this one is the 600 pound force. Okay, 600. Oh, ato lang dako na. Okay, so let's say this is the compressive force. This is the tension force. And then this is the 600 pound force here. So di ba ni-loop siya, it's looping. Marag mo ni siya ang direction niya. So it creates a closed triangular polygon. So let's try to label it. So dire basin ma-shock mo because again, since if you want to use the force triangle, so you will need to use you need to use an advanced technique here. So this one is 600 pounds. This one is tension T. Then this one is the compression C. So 30 plus 45 degrees, this will be 75 degrees. Okay, so if we're going to use the force triangle, so if you're going to look at your unknown figures, so you have two unknown equations and you cannot use the sine law because you're only given one angle. You don't know what angle is this one and this one here, diba? So most of the disadvantage if you're going to use the force triangle. So you have to remember that if you're going to use sine law or cosine law, so the only unknown should be one unknown in that particular equation that you're going to create. So there is even though if you want to really push with the cosine law, so let's say we have 600 squared equals t squared plus c squared minus 2tc cosine 75 degrees. So notice that we cannot solve the system because our cosine law gives us two unknowns. So if sine law, so in sine law, so it should be that only one side is unknown, diba? So 75 sine 75 over 600, and let's say you want to solve for t, so you don't know what angle opposite angle t is, I mean side t is, diba? Or side c. Diba? So you don't know the angle for, so meaning na listed siya if you're going to use the shortcut method. So you only use the shortcut method if you're really confident in answering the problem right away. But if dili, so you have to go very basic. So summation of forces x equals 0, and then summation forces y equals 0. So balik ta sa kuan, di ba? So ako lang tong gi-show ang kuan. Eh basta niya maingon mo nga mas better to ang force triangle. So diri nga problem, so di na siya better, di ba? Isod na pud siya. Okay, so again, if we're going to create a triangle here, so itong pahayagan lang. So the triangle above for the cable is going left and then going upward because tension man siya, di ba? Ang isa is going up still but going to the right. So if we're going to isolate the triangle above, so muna siya ang dagway. This is the tension, this is the unknown force horizontal, this is the horizontal force. Now for the bottom part, for the boom, this is the compression, this is the horizontal component, this is the vertical component. So horizontal and then vertical. And then this is the 30-degree angle. This is the 45-degree angle. So we can now solve it using basic concepts. So the horizontal aspect is adjacent, the 30 degrees. So that's t cosine 30 degrees. So let's start with the kuan lang. With the positive lang, positive value. So this one is positive because it's going to the right. So that will be c cosine 45 degrees and then minus t cosine 30 degrees is equal to 0. So for the y component, so this one is our first equation. So for the y component, we can have the upward force first. So since puro sila upward, and there's only one downward, so just to follow the format, so the compression first. So c sine 45, that's opposite the angle. So plus this time because the y component on the cable is going upward also. So you have t sine 30 degrees. So again, that's sine because it's opposite the angle. And then minus 600 because we have a force going downwards. So next is we rearrange. So we need to isolate the 600 on the other side for us to be able to use the calculator. So 600. So again, mode 5, 1. So again, that's for two equations, two unknowns. So take note that it's following the format. So if you're looking at equations 1 and 2, so the first term is always the compression. But C here and then C here. The second term is the T. The second term is the T. Then on the other side of the equal sign, that's the constants. So this one is equation 1, equation 2, A, B, and then C. So place cosine 45 here, then negative cosine 30 for B, and then 0 for C. And then for the second equation, sine 45, sine 30, and then 600. So compression and tension is equal to So compression is 537.95 pounds. Then for the tension, that's 439.23 pounds. So this is the answer. So for me, just go to the very basic details because mas assured din yung answer, and then you can follow or you can go through the solution again. But if you're confident with the advanced technique such as the sine law and cosine law, so you may also do that particular solution as long as makuha ninyo siya, di ba? Hindi mo maglibog sa advanced technique. So 439.24 then 537.94. So the same na siya, di ba? So this is the solution coming from the book. So if you want to re-answer your problems number 1 and 2, so you may follow the solution for problem number 3. Okay, para maglibog kayo. Ang gi-show sa problem number 1 and problem number 2 are the advanced techniques which utilizes the sine law solution. All right, so do you have questions? All right, so if we don't have any solution, so see you all again on next Thursday for the next topic. So I'll be giving you the assignment in the Canvas course.